My name is Yahir Ortiz, and this is my lab 4 oscillation. So, some introduction. The purpose of this lab, we're gonna analyze a spring mass system, um, observed versus predicted. Observed coming from a video that we're gonna analyze using tracker app, and predicted coming from glow script. Then we're gonna plot the observed and values, and also the predicted values, and compare them and analyze its energy values. So the overall goal of this lab is to determine whether the model follows the energy principle, and if the system's total energy remains constant at 0, then that will demonstrate the energy principle. And here are some formulas used. Obviously, position update, velocity update, grab, and kinetic energy formula are all needed. And here is the energy principle, like written out, which states that a system's change energy is the sum of work done by surrounding and thermal energy exchanged with the surroundings. So yeah, and obviously here's for spring length, which we are gonna need. And another thing to note is Newton's second law, which states that systems change in momentum is proportional to the net force applied. And the thing to note is our system is the mass, spring, and earth, and our surroundings is basically nothing. And here is the video that I used, which was given to us. Calibration was and mass were all given to us, and I calculated everything else. Before we could get to coding, I had to solve this initial condition. Oscillation period, which is T, comes from I got from the observed video, comparing the peaks and then averaging out to get 1.483. And spring stiffness, which can be calculated using the formula above, which I got, and moving things around. So I got spring stiffness equals 4 pi squared times mass over oscillation period squared, and I got 7.216. As for relaxed length, using this formula, which I gave at the beginning, and moving things around, relaxed length equaled initial stretch length, minus mg over spring stiffness, which I ended up getting 0.154 meters. As for my code, obviously ball mass, ball position, I got from the observed video. Spring constant, spring relaxed length of spring we calculated, and as for everything, came from formulas that were given at the beginning. Obviously kinetic energy came from the kinetic energy formula, and total energy just came from adding all things together. F grav came obviously from negative mg equal gravitational force, and velocity update, position update formula, whatnot. Okay, now to analyze our graphs, one thing to remember and one thing to note is that the delta U graph and delta U spring are constantly at opposite, and obviously delta E is at 0. So it's important to remember that. As for my graphs, the two graphs shown here is showing the oscillation function, and obviously they do not overlap perfectly, but obviously it could be because in reality the system is not isolated from the surroundings, so there will be like work done on the surroundings. And of course, obviously I could have like misplaced the center of mass on the tracker app, and it shows because experimentally it looks a bit more jarring. As for the big question of is the energy principle satisfied? Yes, it is, because the sum of all energy is 0. Because the change in spring and gravitational potential is opposite constantly, which is proven by the graph here. Now, what does it mean? Different oscillation periods. different oscillation periods. I calculated X before, but Y I got using the same formula that I used before, and I think it just means that choosing different directions produces deviation in the period, which ultimately affects the spring constant and the graphs. Yeah, thank you.